I just want to say a few words on the French Solid Waste Partnership. We are a multi-stakeholder platform regrouping all the French stakeholders concerned with waste management. That includes the state agencies, local authorities, companies, NGOs, research and training institutes. And our ambition is to have a stronger voice together, to raise the topic of waste management at the highest international level. This is also why we partner with ISWA and other international organizations, because we are stronger together. And before we dive into some examples of mitigation pathways, we'd like to share the importance of the enabling framework within countries to drive incremental change towards a low carbon waste management. And I'd like to excuse Mr. Roland Marion from ADEME, which is the French Energy Transition and Environmental Transition Agency, who was initially supposed to present the case of France and the national regulations and policies. He had to attend some last-minute obligations. But we have the chance to have Paloma Jongou with us, who is the co-author of the publication and can share with us a few insights on policies and regulations with a focus on the case of France. So let me give her the seat because we'd have to do a seat swap for this to work.
Hi, everyone. Thank you for joining in at this webinar. So regarding French policies and regulations, in France, like in many other countries, waste management started becoming a political question when we understood the link it has with public health issues. And so public policies imposed themselves as crucial tools to regulate these impacts and protect the people. And they evolve over time to best respond to the timely social demands and concerns. And so now we're going to ask to what extent public policies, which are influenced by evolving social concerns, are key in guiding waste management actions to mitigate the climate crisis. And so in France, the first big law on waste management was that of 1975. And it tried answering the question, what actually is waste management? So basically defining key notions such as waste itself, but also key frameworks like waste priorities, waste management priorities, sorry, and also, EPR schemes and yeah. And then it was repealed in 2000, and since then, French regulations on waste management have been included into the Environment Code, which shows the social changes and understanding that waste management has a very strong link with environment. And then in 2015, a new shift happened with the focus being put on mitigation measures and actually trying to reduce GHG emissions. And this can be seen as a way of being influenced by international frameworks, who are both the result of top-down processes trying to change waste management practices and habits, but also bottom-up processes, as Corinne mentioned, with national diplomacy and advocacy. And one example of how international frameworks have driven national change is the 2015 Law on Energy Transition for Green Growth in France, which was probably implemented during the Paris Agreement discussions. And this law made GHG assessment mandatory, but it also set the target for carbon neutrality by 2050 in its national low carbon strategy, which we will now be focusing on. It's represented here by this 2018 figure. And so you can see the orange dotted, sorry, I'll try. There you go. The orange dotted line. Oops.
Oh.
Sorry. Okay.
Yeah, maybe you can't.
Yeah, I'll just say it out loud. You can see the orange dotted lines showing the SNBC ambitions. So by 2030, the waste sector should reduce by 37% its GHG emissions, and by 66% in 2050 to reach carbon neutrality, knowing that these 6 million tons of CO2 equivalent that will remain are actually balanced out by absorbed emissions from carbon sinks. And setting ambitious targets and the associated guidelines and roadmaps are key to motivate change. And as shown by this graph, the business as usual, which appears in the gray dotted line, will induce some emissions reduction, but clearly not enough to reach carbon neutrality. So it's crucial to set ambitious but realistic goals, as well as the associated budgets, and also to give, concrete solutions to reduce emissions, to have strong monitoring and data acquisition capabilities, and also to have trustworthy law enforcement. And public policies are then very efficient in making change happen. And we see on that graph how the reduction of landfilling has made a great difference in GHG emissions as of 2000, with the 1999 EU legislation on the topic and the following French laws to adapt this EU regulation to its national context. And although there was a big reduction in emissions, we can still see that there's a stalling curve here. So the ambition of policies can only be fully implemented if all stakeholders are working together and involved to make this happen. So when I say stakeholders, it means those in charge of fiscal policies, but also, in this case, people who are working for the transition to a more circular economy. So that would be industries, but also economists and, just you and I, basic and normal consumers. So here's a few key points that we just went over, but I'll give the floor to Corinne again. Thanks for listening.
Thank you. Yeah, we're running a bit out of time to actually go through these points now, but the deck will be shared when the webinar is over, so you can go through them again. Thank you very much, Paloma, for sharing this case of France. We saw that waste has been more and more diverted from landfills thanks to enhanced recycling and the development of incineration with energy recovery in France. And more recently, there's a trend to want to further reduce our GHG emissions through reducing incineration and through an enhancing source separation and the prevention of waste generation. And that is very difficult to implement. So this is something that we'll see now in the next few cases that will be shared. We have three speakers who will share a few thoughts on mitigation pathways. And remember that then we have a Q&A session that will follow right after these three speakers. So feel free to ask your questions in the Q&A. I'd like to start with a case on incineration by the Cabinet Merlin and Nicolas Almodovar. And he will share about a tool that they have developed to support actually the local authorities better understand what is incinerated and drive reduction actions. Oh, yeah, sorry, I've forgotten I had that slide. So these will be our three speakers that we will have. And now we'll first hear about Nicolas. Nicolas, the floor is yours, and I'll pass the slides for you.
All right, thank you, Corinne. Hi, everyone. So on this case, I just would like to present to you the mass bio2 process. That is a process that enables to assess the two different types of carbon through the analysis of the flue gas in the incineration plants. And the two type of carbons we have is, on one side we have the fossil carbon, and on the other side we have what we call the biogenic carbon. And the fossil carbon comes from mainly comes from the plastic that is still remaining on the solid waste, whereas the biogenic carbon comes from the organic matter that is inside, that's still inside the solid waste. So what the mass bio2 process is allowing us is to have a very nice understanding of what remains in the waste composition, and this by measuring the origin of the CO2 by doing a carbon-14 dating. And then with this algorithm, then we can know exactly what kind of CO2 and what kind of carbon is released in the atmosphere. Because on one side, the fossil carbon, just like we're going to see just right after, is a very long cycle carbon that will remain very long time in the atmosphere. And the biogenic carbon on the other side is a very short cycle, then only remains for what we consider for 50 to 100 years in the atmosphere. And this one is definitely less greenhouse effect onto the atmosphere. And what we have, thanks to Mass Bio2, is the possibility to understand the waste composition with all the results that we can have through the flue gas analysis. And then we can, after this, take all the good decisions in order to reduce the recycling waste that are still inside the solid waste, and then we can act on the collection step, and then we can try to improve the steps before doing only the incineration. So we can add and we can improve the sorting waste before arriving to the waste to energy plants. On the second slide, I just would like to present very briefly. We have, so what I told you, the long cycle carbon that will last for about 100,000 years. And this one is coming from directly the fossil fuels, just like the coal, just like we have the gas, just like we have also oil. And this one is going to emit only some what we call the fossil CO2 that is going to get into the atmosphere and going to accumulate a lot of greenhouse effect inside. And on the other side, we have the biogenic CO2, and this one is going to be a short cycle. And this one, according to the IPCC experts, is not going to have a GHG effect on the global warming. So this is exactly this knowing that we can use to have better actions on the sorting, on the recycling of the solid waste before getting to the final incineration or final landfill or whatever we choose, like solutions. And then the first results of the mass bio2 is on the next slide. We can see that when you burn about 1 ton of waste, you are emitting in the atmosphere roughly, I would say, 930 kilograms of CO2. And 42% of the CO2 that you emit in the air is coming from fossil based products, and 58% is coming from the organic contents. So that is very important to be able to know exactly if it comes from fossil products or organic matter, because that will help you to take the good decision and the good actions before. So that is in kind of terms of solid waste itself. And if we are comparing to the energy on the next slide, then to produce 0.3 megawatt hour of energy, whatever it is, heat or electricity, so 0.3 megawatt hours per tons of waste, then you are going to emit about 140 kilograms of fossil CO2. And if you're burning what I could say good quality solid waste, then you're going to reduce by 180 kilograms the fossil CO2. When I say we're going to avoid 180 kilograms fossil CO2, is compared to the French energy mix. That is, part of it is from gas, part of it is from oil, part of it is from coal. Then that is to say that if you are able to have the best, I would say, the best quality solid waste answering the incineration plant or the waste to energy plants, then you are able to reduce by almost 40% the fossil CO2 that you are going to release in the air. And that is the main point that Mass Bio2 is allowing to the different decision maker, to the stakeholder, in order to take the good decisions and to have a better way of managing solid waste, at least before the incineration plants. And that's what I had to present you by this webinar.
Thank you very much, Nicolas, for sharing with us these insights on waste to energy, so incineration with energy recovery. I'd like now to hand over to Sophie Sicard from PAPREC, who is Deputy Director of Sustainable Development and Corporate Affairs, and she'll share with us a couple cases on sorting at source and its importance. Sophie, the floor is yours.
Thank you. First of all, I would like to thank the French Solid Waste Partnership for giving us the opportunity of introducing those best practices. And a few words maybe about PAPREC. We are a French company active in 12 countries. We handle 16 million tons of waste per year through 3 cycles of resources: recycling, waste to energy, and organic valorization. To give you a rough idea of our contribution to climate mitigation in 2023, our activities, PAPREC's activities, contributed to avoid 7.1 million tons CO2 equivalent emissions. So as Corinne mentioned, to deep dive into our subject, France have a very comprehensive national strategy for waste, focusing on prevention, and now increasingly on sorting at source. I would like to focus on bio-waste and recyclable plastics and cardboard packaging. The first case, I would say, and Corinne, if you can, is bio-waste methanization. The previous speaker highlighted the importance to differentiate between fossil emissions and biogenic emissions. And here, this is the main added value of bio-waste methanization, that it allowed for the production of biomethane, whose emissions are mostly biogenic CO2 emissions compared to fossil methane. With 1 ton of bio-waste, methanization will allow for the production of 1.1 megawatts of energy of biomethane. There is obviously a small direct emission, scope 1 and 2 emission, to produce this 1.1 megawatt. This is 45 kilos CO2 equivalent per megawatt. But the main benefit is that we will, compared to burning fossil methane, fossil natural gas, we will avoid 240 kilos CO2 equivalent per megawatt. So this is the main benefit of this activity. How did if I want to talk about a specific, very local experience, I would like to speak about this partnership and contract that we have with two local authorities in the Paris area, SICTOM and CGF, to produce methane with the local bio waste. To make it very, very, very simple, since January 2024, so since the beginning of this year, it is mandatory in France to have a separate collection of organic waste, not only for companies, but also for households. And what the local authorities in the Paris area decided is that those organic waste collected from household should be orientated toward methanization in order to produce two very valuable products: biogas first and organic fertilizers. Those two production have a very direct contribution to climate mitigation. First, because we will, as I commented in the previous slide, because we will reduce the emissions of fossil CO2 from methane. And second, because we will avoid emissions from the production of chemical fertilizers. With those, basically, how does it work? With those 50K tons per year of bio-waste collected from the Paris area households, we will produce 30,000 megawatts per year of biomethane, of which most of this biomethane will be directly injected into the natural gas network of France, and it will be used for housing, heating, for industrial production, for whatever use is needed. The second product will be 33,000 liters per year of liquid organic fertilizers, which will be orientated toward the Paris, the agriculture areas around Paris, to provide organic fertilizers for 2,000 hectares per year. This would be used for crops and for pastures. Obviously, as you can imagine, there is absolutely the most stringent control on the quality and the safety of those organic fertilizers, which are made from waste. They are submitted to a specific quality plan checked by the sanitary authorities of France. The second mitigation pathway that I would like to share with you is the case of recycled PET. To speak globally, in total, plastic recycling in France avoids 1.4 million ton equivalent CO2 every year, because it allowed for the replacement of virgin plastics made from oil by recycled plastics. If we want to deep dive into this specific case, in about 15 years ago, Paprec and Suez decided to invest into a plant that allows for bottle-to-bottle PET recycling. This means that we will buy actually the waste, the PET waste, PET bottle collected from household everywhere in France, and even for some quantities in other neighboring countries in Europe. Every year we will recycle 45,000 tons of PET bottles, and with those 45,000 tons, we will produce 41,000 recycled PET. This is a food contact quality PET, and as I mentioned, for the organic fertilizers, safety and is our higher concern. And we provide exactly the same quality and safety constraints. We answer to the same requirements than virgin plastics. What are the climate benefits? Basically, this recycled PET will generate 70% less CO2 than PET from oil. This means that every year we contribute to avoid 50,000 tons CO2 equivalent emissions. And as a co-benefit, and this is not a minor one, we obviously help to the sustainability and circularity of the bottled water industry, which is one of the top industry for France. So in here with those two business cases and two climate mitigation pathways, you have really concrete examples of how selective separate collection at source, so at households, and their valorization through recycling and methanization directly contribute to climate mitigation.
Thank you very much, Sophie, for these insights. I'd like to now ask Malik Kerkar from Suez, who's a carbon project director at Suez, to share with us a few thoughts on landfilling. And indeed, for the waste that could not be prevented nor recycled, as we heard from Sophie, landfilling remains one of the most affordable options today. And we'd like to hear from Malik about the emissions associated to this solution, but also the best practices that could or should be implemented. Malik, the floor is yours.
Thank you. Good afternoon, everyone. Thank you, Corinne, for giving me the floor to address specifically landfill waste management and its role in addressing climate crisis. In general, landfill provides an opportunity to significantly reduce greenhouse gas while producing renewable energy. By implementing best practices, landfill emission can be reduced from about 300 kilograms of CO2 equivalent per ton of waste, as shown on the slide, compared to over more than 900 kilos of CO2 equivalent per ton of waste when poor practices are implemented. Additionally, the implementation of good practices allows for important biomethane recovery up to 0.8 megawatt hour per ton of waste. It's an important amount of energy that can be produced from waste. These insights are drawn from a study that has been conducted by Veolia, Suez, and Wager Energy, leaders in the landfill management and biomethane purification worldwide. We have used extensive operational and actual data from the field, from French landfills. However, these findings are applicable to France. They can be extrapolated to Europe, but more importantly, they can also apply to emerging countries facing the same waste challenges. It's important to note that France can target 6 terawatt-hours of renewable natural gas that can from landfill biomethane by 2025. This is quite significant, and it illustrates the fact that optimized waste management practices can align climate goals while contributing to renewable energy production. We can move to the next slide. We'll comment again the same figures, but landfill emissions are a key challenge everywhere in Europe and of course in emerging countries. But improvements are cost effective. It doesn't cost so much to transition from good practices, as you can see on the slide, and which allows you to reduce significantly by nearly 60% your emission related to waste landfilling. In France, we have computed that implementing good practices can only cost 2 to 4 euros per ton of waste. This is a low investment that can mitigate emission, improve landfill efficiency, and this can be scaled up outside Europe on a larger scale. We can move to the next slide, Corinne, if you don't mind. Adopting good landfill practices is critical to reduce emission, especially if we want to address methane emission, as was discussed earlier. Poorly managed landfill often delay methane capture. They use semi-permeable or nearly permeable covers. They rely heavily on flaring, and they increase emission of greenhouse gas while they are wasting the energy potential contained in the waste. Whereas good practices, on the other hand, include early methane capture, implement impermeable covers using geosynthetic or geomembrane. They use advanced technology like bioreactor to maintain optimal condition and the optimal production of landfill gas. These steps not only reduce emission, but they also recover valuable energy from waste, turning waste into a resource. And I think this shift underpins the importance of circular economy in the waste sector that offers the opportunity to change waste into a resource and even contribute with this circular economy approach. Waste can even contribute to climate goals. Can move to the next slide, Corinne. I think now it's important to mention that we have talked about engineered landfill, but there is one step further where we can go, and it's the transition to what we call internally at Suez the green landfill. It integrates advanced infrastructure to reduce emission, as was discussed, and to produce renewable energy, but also it considers all the social and environmental factors. I would like to emphasize the case of Meknes. This is a landfill operated by Suez in Morocco, which demonstrates this approach and the virtue of green landfill. In Meknes, we manage nearly 200,000 tons of municipal waste annually, and we have implemented the green landfill approach, reducing the emission from 70% and allowing important renewable energy production. It's important to note that on this project, we have protected, safeguard the informal sector by establishing a sorting cooperative to support waste pickers. So it's important to ensure climate actions are implemented, but it should not be done at the expense of local communities and the environment. And it's all about environmental inclusivity. So I believe this case of Meknes in landfill, the green landfill in Meknes, show how sustainable waste management can address climate issues while creating co-benefits for people and ecosystem, including in emerging countries. That's okay for me, Corinne.
Thank you very much, Malik, for these insights. This is a very important topic because, as we said, landfilling is still the most affordable option in many countries, and it is really something that by applying the right or the good practices, the impacts of that technology or that solution can really be mitigated, and an opportunity to actually produce energy can be leveraged. Now we have a little bit of time to answer some of your questions. So I saw a couple questions. One of them from Philippe Godard about the injection of natural gas. So I think your question is whether we actually look at injecting directly biomethane into the natural gas grid in France versus using it as a fuel source to power engines or heat and power engines or heating systems. I don't know if Malik or Sophie or Nicolas, if you want to answer that question.
Yeah, I can answer. Yeah, we in the case of the methanization unit that I spoke about, there is direct injection into the network. There is and when the methane is made from waste, there is an epuration step previously to the injection. But yes, the target is definitely to, and this is what we are doing, is the injection into the general network. Part of the methane will be used for to run the operations, to run the production, because there are energy needs for the production process of the biomethane. But the very wider share of it will be injected into the network.
Corinne, I would like to add, this is the same approach on landfill. Previously, in the past, it was commonly, landfill gas that was recovered was not only flare, but it was recovered through electricity generation, thanks to feed-in tariff that was supporting this energy recovery. But more and more, we see in France the implementation on landfill of the purification of biogas into biomethane for reinjection in the network. So it goes with the more sophisticated process. But the technology is proven and widely adopted now in France, and I believe it can also be implemented elsewhere outside Europe or outside the States, and it can be implemented as well in emerging countries.
Thank you. Thank you, Sophie and Malik, for these answers. And I think one thing to highlight is that it is actually more efficient in terms of GHG reduction to inject that refined biomethane into the natural gas grid than to burn it into a heat and power engine to generate electricity, for example. So wherever it is possible, you try to refine the gas and connect it to the grid. We have another question regarding the case about the reuse of recycled materials. So the question is there a strong climate change case to prioritize reuse of certain goods and material streams, such as electronics and textiles? So this is more specific. I don't know if one of you wants to answer that question, and if not, we can also decide to answer later in writing. So,
well, this is this is definitely a specific question. The comment I'd like to make is that there is, at least with the level of consumption in Western Europe, there is definitely some room for both reuse and for recycling. Definitely, we cannot expect the population to rely exclusively on reuse, but there is, and we recognize that prevention has definitely, and reuse is part of the prevention strategy, has a key role to play into climate change mitigation, and then recycling must follow as a way to save resources from extraction.
yeah, so the case is mostly on the savings from extraction of resources that makes the recycling a good case in terms of climate advocacy. And beyond that, if we enlarge the spectrum of thinking beyond just the climate goals, it's the whole limited planetary boundaries, as we call them, that come into play, and the limited resources that we have that plead in favor of both the reuse as much as possible, but also of recycling.